In this video, I want to take a quick look at complex conjugates. Let's first look at the complex number 1 plus 3i. We can graph this in the complex plane with the real number axis as the horizontal axis and the imaginary axis as the vertical axis. Since the real part of our complex number is positive 1, we'll move over on the real axis 1 unit to the right. And since the imaginary part of our complex number is 3i, we'll move on our imaginary axis 3 units up. In order to determine what the complex conjugate of a complex number is, we'll simply change the sign of the imaginary part. So instead of positive 3i, we'll end up with negative 3i. And we can graph this complex number in the complex plane the exact same way. Well, you'll notice the obvious relationship that these two numbers have when we see both of them graphed in the plane. Not only are they simply reflections of one another across the real axis, they also both are on a circle centered at the origin whose radius is the same as the absolute value, or modulus, of each of the complex numbers. The equation of that circle is x squared plus y squared equals 10. We'll come back to that here in a moment. Now, the special thing about complex conjugates is that when we multiply them, we'll always end up with a real number. In this case, we'll distribute the terms to get 1 minus 3i plus 3i minus 9i squared. Since this mimics the difference of squares factorization, we know that when we multiply the complex conjugates, that the middle terms will cancel. And we've seen before that I squared equals negative 1, so we can make that substitution as well, and we end up with 1 plus 9, which is 10. And now we make the connection between the product of a complex number and its complex conjugate with a circle in the complex plane that contains both the complex number and its complex conjugate. We can generalize all of this and show that when we multiply a complex number with its complex conjugate, we'll always get a real number. Let's start with the standard form of a complex number, a plus bi. And by changing the sign of the imaginary part, we'll see that the complex conjugate is a minus bi for any complex number. When we multiply these two together, a squared minus abi plus abi minus b squared I squared turns into a squared minus b squared times negative 1. And finally, a squared plus b squared. All the imaginary numbers cancel, and we're left with the sum of two squares, both which are real numbers. So reminiscent of the difference of squares factorization, later in the unit you'll see that you can use the complex conjugates for the sum of squares factorization. So there's just a quick introduction to complex conjugates and how we can use their product to get a real number quantity. This will have a few implications in this unit, but even more so when you start dealing with real-world applications of complex numbers. So be sure to subscribe to my channel for more upcoming math videos.